So let's have a look at how we would make use of these two formulas. So example 7 here, we're given that f of x equals 3x squared minus 2. We want to find f prime of x, which is what we designate to be the derivative of f of x. So I'm going to use the formula. F prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Which means that if I now substitute appropriately, f of x plus h is going to be the result of me going to f of x, replacing all the x's with x plus h's, which I show in the first quantity. And of course, subtracting f of x is just going to be subtracting the 3x squared minus 2. Now, if you remember, my goal in this is to, when I do a difference quotient, is I want that h that's on the bottom to disappear. And I'm going to explain more as to why we wanted that to happen. But let's do some more evaluation here. If I FOIL the x plus h squared and I multiply the 3 through as well, in the first quantity I get 3x squared plus 6xh plus 3h squared minus 2 minus 3x squared minus 2. I get rid of the parentheses to start combining some like terms, but when I do that I'm going to have to distribute the negative in the second quantity, so I'm now going to have 3x squared plus 6xh plus 3h squared minus 2 minus 3x squared plus 2 in the numerator, and that's over h, and I'm doing the limit as h approaches 0. Again, I haven't done anything with the limit yet, therefore I'm not getting rid of it. Or not, I'm going to continue to write it until I actually make use of it. Now again, remember, we wanted this h to cancel in the difference quotient. You know, that's something we always were adamant about. We always wanted that h to cancel. So, for that to happen, you know, I have to make sure that everything on top has an h in it. There are several things that up here that did not have an h, and as you can see here, they do cancel. The 3x squared and the minus 3x squared, the minus 2 and the plus 2, they cancel. So now everything on top has an h being multiplied in it. Everything on bottom has an h being multiplied, therefore the h's will now cancel. The reason why it was important to get that h to cancel, and now we're left with the limit as h approaches 0, 6x plus 3h. If I had put the 0 value in for h anywhere in these previous steps, I would have ended up with the indeterminate form 0 over 0. And when you get that 0 over 0 indeterminate form, remember, your whole goal, your whole idea is that you want to cause a cancellation to make that 0 over 0 disappear. And it's that h disappearing that was the result, that caused that 0 over 0 to disappear. So that's why it was always important for us to make sure that we got that h to cancel out when we simplified it. Now when it's simplified, I'm not going to get that 0 over 0 anymore. What I'm going to get is I'm going to replace the h with a 0. Notice I'm replacing only the h, not the x. H is being replaced by 0 and h only. Therefore, I get 6x plus 3 times 0, so the result of this is 6x. Now, there's some of you that have had some calculus classes, and you know what the answer is because you learned all the shortcuts as well. You know, you're going to be required in this course, as well when you go into calculus, is that the questions are usually going to be phrased, use the definition of a derivative to find f prime of x if f of x equals blah, 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 blah. When they say use the definition of a derivative, you have to show the limit work and all the algebra work you do along with it. So keep that in mind. That's why I'm having you practice that a little bit here, so you kind of get used to doing that somewhat. So f prime of x does equal 6x here.